Hey guys, today we are looking at 7.2's notes, which is all about adding and subtracting rational expressions. So yesterday's section, 7.1, is all about multiplying and dividing. We looked at simplifying as well. So today we're working on those third and fourth operations with adding and subtracting rationals together. Now we know when we add or subtract two fractions together, we need to get a common denominator. Common denominator. And that's no different for rational expressions, because just like we did in 7.1, when we multiplied or divided our two rational expressions together, we followed those same rules for fractions. We'll do the same thing here. So some of these already have, this first box here, already have like denominators. And again, we know when we add or subtract two fractions together that have a common denominator, the denominator does not change. Once our bases, or our denominators in this case, match, we just do the operation in between the two. So 7 plus 3 is my new numerator over my denominator of 4x. So I end up with a 10 up top over 4x. Once I have them combined together, I have to follow those same rules of simplifying our rational expressions that we did in 7.1. So I'm going to look at top and bottom and see if and or what cancels out, which in this case they're both even, so I can divide by 2 on top and bottom. And I end up with 5 over 2x for my final simplification. I don't need to list any excluded values here because 2 reducing on top and bottom is just a number. It's not a variable that's going to give me a 0 in that denominator like we saw with those excluded values in 7.1. In box number 2, in problem number 2, again, I'm going to just do the operation in between. So this becomes 2x minus 5 up top over x plus 6 in my denominator because my denominator is already the same. Here, I can't factor out anything. 2x minus 5 is factored as far as possible. And there's nothing, like the terms are not the same on both top and bottom. So in this case, that is all I can do for number 2. Last one here in this section. Again, combining them together, I add my numerators over my common denominator of 3x squared. So that gives me 3 over 3x squared. And we can see here my 3's are going to cancel on top and bottom, leaving me with just 1 over x squared for my final simplification. So for this next section, we're looking at what we need to do if I don't have common denominators to start with. So if I don't have a common denominator, first things first, we need to figure out what factors we need to have a common denominator. Right? With numbers, we always looked at kind of what the smallest number was that both of them go into. When we start having stuff more complicated than that, where we have numbers and variables and terms all mixed together, we have to have everything factored out as far as possible first, so we know all of the elements that need to be there in my common denominator. So our first step for finding those common denominators or adding unlike denominators is factoring out my denominators. From there, we'll compare our two lists. What's my least common denominator that includes all of those factors, and then multiply by what's missing before we go ahead and simplify the problem after we've combined them together. So, sounds super complicated, but you'll get the hang of it as we go through and do this. So, some of them don't require factoring at all. In this case, number 4 doesn't really require that first step of factoring it out because 8 and 8x are both factored as far as possible. So what we need to do, I always just think about it as multiplying by what's missing. I need, in order for my common denominator to be there, to have a common denominator, all of my factors that I found in my denominators, and any of my denominators, have to be there for my common denominator. So what I mean by that is, in this case, they both already have 8. So that's good. That's a good first step. But my right fraction here has an x involved. So what I would need to do is multiply my first fraction by x on both top and bottom in order for us to have a common denominator. So in this case, my LCD, if you wanted to label it, my least common denominator is 8x. So then what I'm doing here is just multiplying in order to make both of my denominators 8x. So once I've done that, I have 5x over 8x minus 3 over 8x. So when I combine them, so I'm going to just rewrite that first just to show that step. There we go. And now that I have a common denominator, just like I did up above, I just do my operation for my numerators. 5x minus 3 is my new numerator over 8x, and that's as far as I can take it. Again, there's nothing that I can factor out for my numerator, so I can't cancel anything with my denominator. Something a little bit more complicated for number 5. Number 5, we have some numbers and a variable. So if I'm looking at identifying what my LCD is, I know it has to have an x involved because I had an x over in that right parenthesis, or that right denominator. And then for my numbers, between 9 and 3, the smallest number that both of them are a factor of would be 9. Right? If I was adding 4/9 and a third, I would make my common denominator 9, because then I can make them both denominators of 9. So if 9x is my denominator, I would have to multiply this first fraction by x on top and bottom to make it a 9x. So I end up with 4x over 9x. My right fraction already has 3 and x, so it already has the x value there. That tells me in order to make that a 9, I would need to multiply both top and bottom by 3 in order to end up with a 9x in my denominator. So that's what I end up with here. So 4x over 9x plus 3 over 9x. When I add those together, I end up with 4x plus 3 all over 9x. Again, there's nothing that I can factor out there, so that is my final simplification. Okay, next one here. For number 6, we have 5x over x squared plus 7x plus 10 plus 4 over x plus 5. So now I actually do have that first step that I need to do from the instructions right up above this box. I have to factor out my denominators. This is just regular old school 2 parentheses factoring. I'm trying to figure out what multiplies together to get 10 but adds up to 7, which would be positive 2 and positive 5. So I know that that first denominator factors out into x plus 2 times x plus 5. So my LCD, my least common denominator, has to include all of the factors that I saw in my denominators. So my first denominator had x plus 2 and x plus 5. My second denominator has x plus 5. So if my LCD includes all of the different factors that happened in any of my denominators, I only had 2 factors, 2 unique parentheses in this case, that gave me my denominators, x plus 2 and x plus 5. So if I have to get in order to get a common denominator, what needs to happen, that first fraction already has both factors that happened in my denominator, so I don't need to mess with that first one. But this second fraction only had the x plus 5, so I'm going to need to multiply both top and bottom of that second fraction by x plus 2 in order for it to be a common denominator. So what I'll do when I rewrite this, I'm going to do this in red here. My first fraction does not change, x plus 2, x plus 5. Plus, I'm going to go ahead and distribute. 4 times x is 4x. 4 times 2 is 8. And that's all over. I leave these factored out. X plus 5, x plus 2, which order doesn't really matter here. You can see I switched around. That's not important. But I leave my denominator factored out because at the end we know we're going to have to check to see if anything cancels out, if it simplifies at all. So I'm going to leave it all factored out in my denominator. That way it's easy to identify if stuff is going to cancel on both top and bottom. So adding together, 5x plus 4x is 9x plus 8 all over x plus 2, x plus 5. And I just have to check to see if my if my numerator factors out at all, so I can see if anything cancels. Which 9 and 8 don't have anything in common, so there's no GCF. It's not anything that's factorable. So this, once again, is my final simplified form. Okay. So on the back side, we've got a couple more examples that we'll do together. We've got 3 more, and these will be a little bit more complicated, so, prepare yourselves if you need to. But it's the same basic process we're doing for all of them. We're starting off by factoring out any of my denominators that need factoring. So in number 7, my x squared minus 16, that's my difference 2 squares shortcut. That factors out into x plus 4, x minus 4. I'm not going to require that you formally write out what the LCD is unless the problem asks you, hey, what's the least common denominator for these fractions? So you can just kind of factor it out for yourself, and then I usually just jump right into multiplying by what's missing. So I knew that first fraction had x plus 4 and x minus 4. My second fraction just has the x plus 4, so it needs the x minus 4. From here, my first fraction has not changed. 16 over x plus 4, x minus 4, plus in between. I end up with 2x minus 8 for my numerator on the second parenthesis. X plus 4, x minus 4. So when I collect up my like terms, I end up with 2x plus 8, right? Because 16 and negative 8 is positive 8, over x plus 4, x minus 4. And now I do have something that factors here. My two factors out up top leave me with x plus 4. And I still have x plus 4, x minus 4 in my denominator. So now we see with this, I do have x plus 4 on top and bottom that cancels out like we did in 7.1. And my final simplification is 2 over x minus 4. But again, we saw something that was canceled out. I saw something that was in my denominator to start with that is not anymore. So just to remind us to figure out what that restricted value is, we just set the canceled thing equal to 0 and solve. So here, minus 4 on both sides tells me negative 4 is that restricted value. So in my answer, I just also indicate, along with my simplified solution, that x cannot be negative 4. Because again, if I had x equals negative 4 in my original problem, it would have given me a denominator of 0, and that's not allowed. All right, number 8. Both of these have GCFs, so we'll start there. This is 6 times x minus 3. My second denominator has a GCF of 2. That leaves me with x squared minus 5x plus 6, which factors one step further as well. 2 is still out there, but this is just regular old school 2 parentheses factoring. Negative 2 times negative 3 is positive 6, but negative 2 plus negative 3 is negative 5. So that's what that factors out into. So now I will write my LCD out here because it is a little bit more complicated. But for my numbers, just the numbers, between 2 and 6, the LCD would be 6. Right, 6 is the smallest number that both of those go into. And then I have two unique factors, x minus 3 and x minus 2, that show up in my denominators. So all three elements of that LCD need to happen in order for us to have a common denominator. So that tells me this first parenthesis, this first rational expression, is just missing my x minus 2. It already had the 6 and the x minus 3. So up top here, multiply by x, whoops, don't need two parentheses, x minus 2 on top and bottom. My second fraction, my second denominator, already has the x minus 2 and the x minus 3, and it has a 2 out there, but we want that to be a 6. So all we have to multiply in my second fraction is 3 on top and bottom. Because 3 times 2 would give me my 6. It already had the two parentheses that we needed, so there we go. So when I rewrite this, after I multiply by x minus 2 in the first parenthesis, or the first fraction, I end up with 5x minus 10. And here, just until I get down to my answer, I'm going to just use shorthand and just say, hey, over my LCD, it's plus 3x minus 3 is what I get when I distribute my 3 into x minus 1 over my LCD. So then once I combine my like terms, I'll rewrite it with my actual LCD in there. So 5x and 3x is 8x, negative 10 and negative 3 is negative 13, and then my LCD was 6 times x minus 2 times x minus 3, and I would put that in there now because I should check to see if something cancels, which 8x minus 13 does not factor at all, so I can't factor anything out because 8x minus 13 wasn't in my denominator either. So that is my final simplification for number 8. All righty, last one. Last one here for number 9. The nice thing here is that I can't factor either of those two, right? 3x minus 1 does not factor. There's no GCF. It's just a single term. There's no squared or anything. My x plus 1 doesn't factor at all because it's just a regular binomial. So that's nice. I don't have to factor. The thing that kind of stinks about that then is that I just have those two unique parentheses. So what I have to do is just basically multiply my other fraction by the other denominator. So what I mean by that, I have x plus 1 in my right fraction. It's missing the 3x minus 1. So I'm going to have to multiply by that on top and bottom. 3x minus 1. My first fraction has the 3x minus 1, but it's missing the x plus 1. So I'm going to multiply by that on my first fraction. So I'm going to have to FOIL up top. So up top, x plus 1 times x plus 8 gives me x squared plus 9x plus 8 over my LCD of x plus 1, 3x minus 1. My right fraction, a little bit more complicated. We got, let's see, 3x squared is negative x, positive 9x, so that's a positive 8x minus 3. Now, if you guys need to do that scratch work off to the side, that's totally fine. All I'm doing to get those is just foiling, right? Firsts, outsides, insides, lasts. Firsts, outsides, insides, lasts. So again, I'm just saving up some time here, but you can go through and FOIL that step as well. So now to combine those two fractions together, we have a common denominator. I'm allowed to add the numerators up. So x squared and 3x squared is a 4x squared. 9x and 8x is a positive 17x. And then 8 and negative 3 is a positive 5. All over x plus 1, 3x minus 1. So I've got a leading coefficient here of 4, which means I can't just use regular 2 parenthesis factoring. I don't know for sure whether or not that factors out, so I'm going to have to use Xbox factoring to factor it. So remember, for Xbox factoring, it's always my first term times my last term. So 4x squared times 5 is 20x squared. And then my bottom is always my middle term. So I have to try and figure out whether there's two numbers that multiply together to give me 20, but add up to 17. So if you need to make a list for yourself, 1 and 20, 2 and 10, and 4 and 5 are our only 3 combinations that multiply together to give me 20. That one adds up to 21. This one adds up to 12. This one adds up to 9, which none of those are 17. So that tells me that my numerator here does not factor. 4x squared plus 17x plus 5 does not factor any further. So that is my solution. Alrighty. So that is all I got for you guys for today. The homework is printed down there at the bottom that you guys will work on tomorrow. It's on page 388. You guys have 4 through 26, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.